Hey guys, welcome back to another mixtures video, okay? This time I'm gonna talk about special mixtures. Does anybody know what those special mixtures are called? Those special mixtures are called solutions, okay? So a solution is a mixture, okay? If you did not know that, guess what? I didn't know that either. But a solution is a mixture because it's two or more substances put together, okay? Sometimes when those mixtures combine in a uniform way, okay, they're turned into a single substance, or it looks like it's one substance there. So it's evenly distributed, okay? So the items or the substance you cannot see, it seems like it disappears. Still there, we can probably taste it, we can probably see the different color, okay? But it's still there. It just seems like it disappeared into the other substance. Okay, so we're gonna do a couple of experiments there, and we're gonna find out what causes that, and then why our solutions mixtures. Okay, which they are. They're just some special ones. Okay, so let's see. Okay, so the first one I want to talk about is a regular mixture, which is what we've done before. When you mix two substances together, this time I'm gonna mix oil, which is vegetable oil, and I'm going to go ahead and mix water. So oil and water, okay, that's the most simplest I can go, okay? When I mix them both, and I'm gonna go ahead and mix them, I get oil and water, and of course I cannot cheat, so I have to spin it, okay, or give it a little stir. Now, when I stir it, it may seem that, oh, they're combining, they're joining forces, is becoming one. And yeah, it does look like that. And I'm gonna try it as fast as I can. I promise you, I'm trying to stir it to where they're stuck and combined together. But guess what? Doesn't matter how much I stir, eventually, and unfortunately or fortunately, they do not mix. Okay, you've probably seen this at home, but they do not mix. Oil and water do not mix together. You see those little tiny bubbles down there? That's oil. Eventually it's gonna go up because oil, like we learned before, oil is less dense than water, therefore it floats. So because it doesn't mix, it is insoluble. The oil is insoluble into water. Okay, that's why whenever there's an oil spill in the ocean, most of the oil is floating on top of the water, and it's better than it sinking all the way to the bottom, I would think. Maybe not. Maybe I'm wrong. Okay, but maybe I can do some research on that. But but right now, the oil floats over the water, and you saw me stir it, right? And guess what? Did it mix? Did it become one substance, one uniform substance? No, it's two different substances, okay? This right here is a regular mixture. It's still a mixture. It's, yeah, you see two different things put together, but it does not dissolve into another. It's not a uniform mixture. Therefore, it is a regular mixture, okay? So, regular mixture right here. I'm gonna go ahead and do another mixture. And this is a pretty cool one. This one right here is, I'm gonna do blue dye, which is food coloring, and some water again. Okay, and then of course I'm gonna have to stir it like I did with the oil to give it a fair chance, correct? Okay, so what do you guys predict is gonna happen? What do you think is gonna happen when I put these drops of food coloring in there? Is it gonna happen like the oil and water? Are the food drops gonna be on top? Or are they gonna go to the bottom? Maybe they're more dense. Okay, what do you think? Let's see. I'm gonna put about 2 or 3. Okay, so I put them in there, and as you can see right away, okay, it's starting to spread out. Now, it's not spread out evenly, but guess what? If I leave it overnight, eventually it will spread out evenly, okay? I will try it. I promise you, I will try it, okay? But right now, I'm going to go ahead and stir it and give it the same chance I did with the oil and water. Okay, so I'm going to stir it, and by stirring it, you're going to start to see that that color that we saw disappeared and it turned evenly blue. So the beginning, the top part is blue, as well as the bottom part is blue. It's all the same. Notice this is a uniform form of a mixture. It all looks the same. The first part, the second part, the third part, the fourth part, all the way to the bottom, it's all the same. And because of that equalness, if that's a word, because of that, we have a special mixture. Okay, this special mixture is called a solution. Okay, that's when the substance dissolves into the other substance. Okay, a solution, special mixture. One dissolves into another. Okay, those are important terms we need to listen to and hear. Okay, what are some other solutions that you've seen at home? Maybe you've seen them somewhere else in the nature, like the beach. Okay, so yes, salt water. If you were thinking salt water, I know you were, because I said the beach and you're like, oh, salt water. Yes, perfect. Salt water is a solution. That's water and salt. You can't separate them easily. Okay, you can't go and say, oh, I want some salt and take it off of there. No, it's bonded together. It's bonded together. Well, the molecules are bonded together. The salt is stuck to the water molecules. Okay, and there's only one way to separate it. Okay, here with the oil and the water, we can separate this easily. We know that the top is more dense or less dense. Very good. The top is less dense compared to the water. So we're separating this substance by density. Okay, so we can separate it by removing the top layer. Okay, I can slowly pour it out until I remove all the top layer. I can get a spoon and remove it easily. So it's pretty simple. The hard part would be not the oil and water, but the solution here. Okay, this solution, how can I separate the blue dye from the water? I can't grab it and separate it. What do I have to do? Very good. I think you got it. You have to boil the water. When you boil the water, it evaporates the water into the atmosphere. When the water evaporates, we are left with the blue dye. It should be all the way around at the bottom. Same thing with the water in the ocean. How can I separate the salt from the water? You have to evaporate the water. By evaporating the water, everything else that doesn't evaporate at that temperature will stay inside the container or the beaker or the floor or wherever you're leaving it to evaporate. That's where it's going to stay. Okay? And you're left with nothing but blue dye. Okay? All right. So, final questions. What are some other solutions? Okay? Again, you could comment them below. Make a list, write 10 comments. It's okay. As many as you need for solutions. Make sure you type in solutions and then give me examples. Then I also want you to write several regular mixtures that seem to be solutions, but they're not. Like, for example, sand and water. So whenever you go to the beach, you see sand at the bottom, then water or salt water on top, right? Did you know the sand does not dissolve? Okay? The sand doesn't dissolve, and because it doesn't dissolve, it stays at the bottom. That means it is more dense. And again, it is easy to separate because it is more dense. All right, guys, so that's everything I have for you today. Thank you guys for watching. And remember, special mixtures, they bond together. They appear to be one, okay? mixtures that are appear to be more than one substance, then those are regular mixtures, okay? And those are the ones that are easily to separate or easier to separate than the ones that have bonded and become a that become a solution, okay? All right, guys. I hope you got something out of this. I will be uploading more videos, so make sure you comment, you answer my questions, at least answer them, mentally. That way, or you've practiced some. Okay. All right, guys. So thank you so much. I will see you guys next time. Bye bye.